Hi guys, welcome to lesson 7. So before the break we started talking about decimals and we really realized that decimals aren't that scary after all, right? Right. So today we're going to be talking a little bit more about some of the patterns that we have seen working with decimals. So go ahead and open up to page 137. And we're going to look at where it says model it decimal point patterns. So in number 1, it says the diagrams below show patterns in the placement of the decimal point each time you multiply or divide a decimal by 10. So complete the missing numbers in each diagram. The decimal point for each missing number is already placed for you. So for the first one, you have a table that looks like this, and there's 1, 2, 3, 4, 5 sections to it. And so remember, each time we're moving up, we're multiplying by 10. Okay, so these are each multiplying by 10. And then each time we go down a place value, we're doing the inverse or dividing by 10, right? So they've given us some numbers. They've started us with, in the second box, 5.0 or 5 and 0/10, right? Then in the box below that, we have 0.5. 5 is in the tenths place, so we're going to say that we have 5/10. And then below that, we have 0.05, or 5 in the hundredths place, so we have 5/100ths. So now we need to think about where our place value would go if we divide by 10 again. We're going to have now one more place value from the right, right? So our decimal point, if we think about it moving, when I divide by 10, I'm moving my decimal point. I'm going to go ahead and one place value over to the left, right? So now instead of 5.0, I have 0.5. Now if I divide by 10 again, I'm going to move that decimal place one more over. Now I have 0.05. We can go ahead and kind of ignore this. If I divide by 10 again, I'm going to move that decimal place one more over. And I'm going to get a 5 in the thousandths place, or 5,000. Now that's if we're dividing. So if we divide, our decimal place starts to move over to the left. If I'm multiplying, it's going to move over to the right. So let's use our example again of 5.0. If I multiply by 10, my decimal place is going to move one place value over to the right now. And so instead of 5, I get 50, right? And we could even mark it as 50 and 0/10, but it would still stay the same. The value would still stay the same as 5 in the tens place, or 5/10 or 50. Okay, so that's the first table. The second table looks very similarly, but this time we're going to be working with 27 and 0/10 as the middle number that we're starting with. So now, okay, if I divide by 10, I'm going to move my place value 1. I'm going to move my decimal point one place value to the left. So my new decimal place value would fall in between the 2 and the 7. So I would have 2.70. So now I have a 7 in the tens place. But because I still have my 0 here, I'm going to call it 70/100ths. But 70/100ths is really the same as 7/10, right? And we can see that it has the same value. The 7 is still in the tenths place, But when we have another, when we have a 0 next to it, we would have 70 hundredths. That's going to be really important because when we start moving to multiple numbers in decimal places, like if we add a 3, we would have 2.73, which would be like saying we have 73 hundredths, right? So I still have a 7 in the tens, but I also have that 3 in the hundredths place, so I have 73 hundredths. Now, if that seems confusing to you, don't worry, because we're going to be covering it in subsequent lessons, but it is worth mentioning right now. So we're going to go ahead and just switch that back to 0. So I moved my place value 1 over to the right. No. So my decimal place actually moved 1 place value over to the left. Now I'm going to move it over 1 place value again because I'm dividing by 10 again. So now I'm going to have 0.270 or 270 thousandths, right? Okay. Yep, that's still right. Okay. And we can also take out those zeros and still be left with the same amount. So zeros, just like in our numbers, if I have 100, I could have a 0 on this side, and my digits would still fall in the same place values. So zeros can change the value, because now instead of having 100, I have 1,000, right? But sometimes where we add them isn't going to change the value of the overall number. So again, if I have a 0 in front, not going to change it. If I have a 0 here, we would call it 70 hundredths, but it still has the same value of 7 tenths. Here I have 27 hundredths. I could say that I have 270 thousandths, or I could leave it as 27 hundredths. Okay, so that's going down, decreasing our size. Let's go ahead and bump it up. So now I'm going to multiply by 10 to go up to the next, and that means I'm moving my decimal place 1 value to the right. So now I have 2, 7. My decimal has moved over here. So now I have 270. And we can think about it as 270 and 0 tenths, right? That's not going to change it. But when I move my place value, my decimal place 1 more place value over, I'm going to have 2,700. And I could say 0 tenths, or I could leave that off as well. All right, so that's for number 1. We're looking at those patterns again. Remember, when we multiply by 10, our value increases, our number gets bigger, and our place value moves to the right. Our decimal point moves to the right, rather. When we are dividing by 10, we're decreasing or getting smaller, and our decimal place is going to move to the left. All right. Now for number 2, it says use decimal point pattern diagrams above to help you find each product or quotient. So let's go ahead and look at the first one. The first one has 0.5 times 100 equals blank. So let's go ahead. Remember, just like our work with multiplication, when we have a problem that we don't know how to solve, oftentimes we'll think about how to make the problem easier. So how I'm going to make this problem easier is I'm going to temporarily ignore that extra 0, because I know that if I have 5 tenths multiplied by 10, that's going to give me the same thing as 5, right? I've moved my decimal point 1 place value over to the right. So we could say it's like 5 and 0 tenths. But I'm actually moving it 2 place values over, right? Because I'm multiplying it by 10 again, which would give me a total of 50. So let's go ahead and see that again in slow motion. I start with 5 tenths. I multiply it by 10, and my decimal place moves 1 place value over. So now, oops. Yes, no, that's right. So now, instead of 5/10, I just have 5. I'm going to multiply it by 10 again because 10 times 10 is the same as 100. And my decimal point is going to move one more place value over, resting here now, giving me a total of 50. All right. On the next one down, we see 0.5 times 10 with a little 2 next to it. So that's 10 to the power of 2, or 10 times 10. 10 2 times, 10 times itself. So remember back to when we were talking about square units, right? So we're talking about if I have a square, this side is, let's say, 2 inches. This side is also 2 inches. This side is also 2 inches. And so is this side because I have a square, right? So all the sides are the same. So when I talk about square units, in this case, I would have inches to the second power, or squared, right? Because I have squared my 2 inches. Now in this case, that would be the same as saying I have 2 times 2. Remember, length times width is going to get us the area, or 4 square inches. So now, if I'm doing 10 squared, that's going to be like thinking of 10 times 10, right? 10 to the power of 2, I have 2 tens that I'm multiplying by each other. So this little number, remember, is called an exponent. So exponents, we typically work with 2, which we also call squared, or 3, which we also know it as cubed. But really, you can go ahead and make an exponent as any number. It's going to be the number that you have the exponent by multiplied by itself that many times. So let's go ahead and just change the problem again really quickly. If I had 10 cubed, I would have 10 times itself 3 times, right? If I have 10 to the power of 4, I'm going to have 10 times itself 4 times, okay? But let's get back to our original problem. 10 to the power of 2, or 10 times 10. Well, we know that 10 times 10 is another way of saying 100, and we actually just did this problem. 0.5 times 100, I'm going to move my decimal point 2 place values to the right. So instead of having 0.5, I'm going to have 5. If I move my decimal point to the other side of the 5, that would be 1. Move it over to the other side of the 0, that would be 2 place values over. And the way I remember this is that there are 2 zeros in 100, so I'm moving it 2 place values over to the right if I'm multiplying, okay? Same kind of principle as when we're multiplying by powers of 10. We can take away those zeros and then add them back in. Same general principle applying here. I have my place value. I'm going to go ahead and move it over however many zeros that I have. Okay, let's go ahead and move on. The next one says, now they're changing it, and I have 5 divided by 100. So remember, we can think of this the same way as 5 out of 100, or 5 100ths. So if we were going to write that as a fraction, if we were going to write it as a fraction, we just did. It's already there, 5 out of 100, right? But if I'm going to write it as a decimal now, because we're working with decimals, I'm going to write it with a 5 in the hundredths place, because I have 5 100ths. So 5 in the hundredth place would be 5 hundredths. We can also double check this because my decimal point is going to be moving 2 place values over to the left. So let's just double check and make sure that I did that. If I think about 5, I can think about it as 5 and 0/10, right? So if I move it over 2 place values over, all of a sudden I have 5 hundredths, okay? Okay. So the last one says, now I have 5 divided by 10 to the power of 2. So even though we're dividing, whenever we have an exponent, we're going to think that that number multiplied by itself, it's going to be there 2 times, right? So I have 10 times 10, 10 to the power of 2. So that's like 100, which we just did. So it's going to be the same answer. I'm going to have 5 out of 100, or 5 100ths, 5 in the hundredths place for that one. Okay, what I would like for you to do is to go ahead and do the ones with the second column. Do those on your own, pause the video, and then come back to check your work. Okay, so now that you have unpaused your video and you've already completed the next 4 problems, let's go back and check. So you have 0.27, or remember that's like 27 hundredths, because we always talk about it in terms of what the last place value is. So 27 hundredths, I'm going to multiply that by 1,000. So in 1,000 I have 1, 2, 3 zeros. So I'm going to be moving my place value, 3 place values to I'm going to be moving my decimal point, rather, 3 place values to the right. So that would put it boop, boop, boop. If I move things around a little bit, I would now have it on the other side of 1 more 0. So I would have 270. So once again, let's look at that in slow motion. Instant replay, 0.27. Okay. So we can think of 1,000 as like 10 times 10 is 100. 100 times 10 is 1,000. So I'm going to move it 3 place values over. It's like I'm multiplying it times 10 3 times. So 1, 2, 1, 2, and then, oops, didn't align that very well. 1, 2, 3. So my new decimal point is going to be on this side. If I erase my trail, my number would look like this. And I no longer need that 0 in front of it. I can just call it 270. Okay? Now the second one is showing you 27 hundredths, or 0.27, times 10 to the third power. Well, guess what? We just did that. We had 10 times 10 times 10. I have 3 tens. That's the same as 1,000. So our answer would still be 270. So the answer for the first and second problem are the same. You would get 270 for both of them. All right, now we're going to divide. So remember, we're going to be moving to the other, our decimal point to the other direction. So we're going to have 2,700 now divided by 1,000. Okay, so I'm going to use my little trick of counting zeros. I have 1, 2, 3 zeros. Right now I have my place value right here, or my decimal point right here, right? So I'm going to be moving it 3 place values over to the left because I'm getting smaller. So that's once, twice, 3 times. This is going to be my new decimal point. So we would write it as 2 7/10. I could include the other zeros, but really that's just like saying I have 700 thousandths, 70 hundredths, 7 tenths. They're all going to be the same thing. All right. So the next one, I think you probably have an idea where this is going. It's taking 1,000. So now we're going to call it 10 to the power of 3. So remember, when we're thinking about it, we're saying that's 10 times 10 times 10, which is still 1,000. So we're still going to get the same answer. We're going to be moving over 3 place values, 1, 2, 3. We still get 2.7 or 2 7/10 as our answer. All right. On page 138 now, we have some more place value charts. Number 3 says complete each row with the product shown to the right of that row. And it's getting late in the day, so my hair is getting kind of crazy. Oh, that's a little bit better. Nope. Okay, that'll do. All right, so number 3, you have ones, tenths, hundredths, and thousandths on your chart. So we start off with 0 in our ones place, our decimal point, 0 in the tenths, 0 in the hundredths, and 5 in the thousandths, or 5 thousandths, right? Now on the next row, they're saying that you're going to take 0.005 or 5 thousandths, and we're going to multiply it by 10 to the power of 1. So that's like multiplying 10 only one time. So that's going to move our place value over just one place to the right. So instead of having, so that would be like, now it's here. So we went from 5 thousandths to 0 in the ones, 0 in the tens, 5 in the hundredths, and 0 in the thousandths. Now the next one has 0.005 times 10 to the power of 2. So that's taking our original number. But now I'm going to move my place value over, group. So now all of a sudden my 5 is just on the other side of my decimal point. And I continue to have zeros in the remaining spots. Last one, 5 thousandths times 10 to the power of 3. I'm going to move my decimal place one more over, and so now my 5 is going to be moving over to the left, which I know is confusing because when we multiply, we were talking about our decimal place moving to the right, but our number has shifted each time to the next place value to the left because it's getting bigger, right? So 5 hundredths is larger than 5 thousandths. So I think of it like our place value moving to the right, but it's like our number, we could also think of it like our numbers are shifting to the left, but really we're saying the same thing here. We now have our 5 on the other side of our decimal place, so we have 5 ones and 0 tenths, hundredths, and thousandths. All right, now we're going to do the same thing for number 4, but instead it says show the quotient to the right of that row. So we're going to still start, actually this time we're going to start with, we're going to go backwards. We're starting with 5 ones, 0 tenths, hundredths, and thousandths. Now instead of multiplying, we're going to be dividing. So we're going to say we have 5 divided by 10. So we have 5 tenths, right? Because we're thinking of that as a fraction as 5 tenths. We know that our 5 is going to move to the next place value over, and we could write it like this. Now, if I have 5 divided by 10 to the power of 2, that's like saying I have 5 out of 100, or 5 hundredths. So now my 5 is going to move to the hundredths place. And the last one, I have 5 divided by 10 to the power of 3. That's like 5 out of 1,000, or 5 thousandths. My 5 is going to migrate one more place value over to be in the thousandths place. All right. Number 5 says, look at the first decimal point pattern diagram and the place value charts. How do the position and the value of the digit 5 change when multiplying and dividing by 10. So when we multiply, our digit is going to move one place value to the left, or our decimal point moves one point over to the right. If we are dividing by 10, then our 5-digit moves one place value over to the right, and our decimal point moves one place value over to the left. Either way you think about it, when you're multiplying, your number is increasing. When you're dividing, your number is decreasing. You're getting smaller pieces, remember? So we're thinking about it as we take a whole, 0 to 1. In the first one, we're going to divide it into tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal pieces. Then we're going to divide it those tenths into tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You get the idea. And then I'm going to take each of those hundredths and divide it by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm getting smaller and smaller pieces each time, right? So now I'm just dealing with this fractional piece right here, dividing it into tenths. So ultimately what you're looking for number 5 is that when you multiply by 10, your place value is going to increase by one place value over. When you are dividing by 10, it's going to decrease by one place value over. You're going to get one place value smaller. All right. Number 6, show how to find the product of 0.19 or 19 hundredths, because the 9 is in the hundredths place, by 10 to the power of 3. Okay. So if you're going to show this, we have 0.19 times 10 to the power of 3. So you could do this a couple different ways. You could show this a couple different ways. You could show it 0.19 or 19 hundredths times 10 would get you 1.9, right? 1 and 9 tenths. Then I take 1 and 9 tenths, multiply it by 10, and I get 19. Then I get 19 and multiply it by 10, and I get 190. So I've multiplied by 10 1, 2, 3 times. We can also do that, though, by thinking of it as 0.19 as multiplied by 10 to the power of 3, which we also know would equal 1,000, because that's like saying 10 times 10 times 10, 10 3 times. 10 times 10 is 100, 100 times 10 is 1,000. So we're just going to combine those steps and say I have 19 hundredths times 1,000. I have 3 zeros, so I'm going to move my decimal point 3 places to the right because I'm multiplying. So I go 1, 2, and I need to add one more 0 to make it 190. Either way, both times you're going to get a product of 190. All right, go ahead and turn the page. On page 139 and 140, we will be covering these in our practice session on Thursday. One more turn of the page and you get to pages 149, 142, or I'm sorry, 141 and 142. Those you are welcome to do for some extra practice, which I would highly encourage if you are feeling a little bit insecure on some of these, on some of how the decimal point movements work. But again, it is optional. So I hope you guys got a lot out of this video, and I will see you on Thursday for our meeting. All right, bye.